I want to share with you yeah. Assalamualaikum and very good morning. Yesterday I learned very much from you, especially you as the user of statistics, which is very different from the way statisticians are working. Okay? User of statistics, they use the tools provided in the statistics. But as statisticians, we produce the tools for you. So we go beyond using statistics. We go beyond using statistics. We produce statistics. Okay? And this morning I would like to talk about how we can identify the behavior of rainfall occurrence in peninsula. And for that purpose, we are looking the behavior of rainfall from multivariate analysis point of view. Why? Okay. Before we were there, this work is joint work done by 7 persons. Because the task is very, very heavy, very voluminous. So, 2 from the spam, one is number 3 over there, is working on data collection. It's very hard to collect data, and then how to transform data into a suitable form. It is done by Djauhari from UTSM. And then how to create MATLAB code. It was done by Lee and Revati, and how to deliver the result of computer processing in the form of complex network. It was done by Mansoureh and Zunaim. Okay? And I myself, I direct the whole persons. Okay? Look, before I start, I would like to remind all of us about what George Box said in this journal, Journal of Quality Technology, the most prestigious journal in the world. In 1972, he said, all models are wrong, but some are useful. Okay? So, when I was sitting there, hearing all the presentations, and as long as you are happy with the model, and it is not dangerous, I cannot give any comment. But as long as it is dangerous, then I will give you my comment. Okay? Now I would like to start with how we recognize the behavior of rainfall occurrences in Malaysia. Look, imagine the whole peninsula. statistically, peninsula is a set of infinite points, infinite location. Yeah. Infinite points in terms of longitude, latitude, and altitude. Okay, infinite points. And the rainfall in one point will influence the other points. So there are infinite relation between locations in terms of rainfall. Okay, so this is mathematically, this is a complex system. Yeah. How do you learn from that complex system? Okay. In statistics, complex system is then sampled in the form of complex network. That is what I want to present to you. Yeah. And then infinite number of locations becomes finite, and relations among infinite number of locations become finite relationships, and most importantly, linear relationship. Why linear? Because all statisticians are working mathematically, are working in the spatial space, what we call Hilbert space. Yeah. There, when we are working with in statistics, there is the space, yeah, where you are working on. Okay, so you cannot escape from multivariate. Okay. Then by using multivariate, complex network is transformed into correlations network and disability network. Okay, that is the flow of your mind. Okay, now sample point. We collect 720 locations. Oh no, I mean we do not collect, but we go into that link. Yeah, belong to NASA. Yeah, they provide 720 locations in peninsula, and data available from 1998 until 2012, and each hour there are 8 observations. So this is a very big data set. Yeah, very big data set. How many data set? Okay. We are now in big data set era, right? So this is an example of the structure of the data. We focus just only data in 2012 only. Yeah. Okay. Then what we have to do with this kind of data? Yeah. Your data here is a matrix. Yeah. How many columns? Matrix 720 columns. How many rows? 8 multiplied by 24 multiplied by 365. Around 70,000 rows. And the challenge is that each column is a time series. Be careful with time series. Be careful. Not all statistical tool can be used in that kind of data. Yeah? Generally, when you are working with statistical tool, generally data must be independent and identically distributed. With time series, this is another story. Please be careful with that. Okay? Then, yeah. Yesterday, the whole day, all presentations were focusing on exploratory analysis, not confirmatory. In statistics, there are two types of data analysis: confirmatory or exploratory. Yeah. Yesterday, the whole papers are about exploratory, not confirmatory, not dating. Confirmatory is the study of the past until present. Exploratory is the study about the future. Okay. Okay. How to construct complex network of rainfall behavior? Look, from time series data, we have to transform into the occurrence of rainfall. You cannot use Pearson correlation coefficient. Okay? So, I think not too many people heard about Prof version. So I introduced the use of Prof. But the original form of Prof doesn't include the direction, whether positive or negative. And now I develop Prof, yeah, in order to know the direction, whether the correlation is negative or positive. Yeah? So, okay. This is the structure of Pro correlation matrix. Look, what is the meaning of this? The correlation is 0.7. That positive. Look, positive. That if location 1 is rainy, location 2 is also rainy. If here is dry, here also is dry. Okay? Some are negative, and even one. Yeah. There are some locations with correlation 1, meaning that if in one location is rainy, then at the other location, yeah, will also rainy with probability almost 1. Interesting. So when the correlation is high, why don't you focus on some locations, not all locations? Okay, and even this is look negative. Yeah, I just saw a small value in absolute value, yeah? But some are negative, large negative. What is the meaning? If here is rainy, then here is dry, right? Yeah. Look. Okay. I want to remind all of us. Do you know Chef Wan? The best cook of Malaysia? Yeah? Every time he shows how he cook, he always present a new recipe. Right? That's the job of statistician. Yeah. Every time statistician stand up in front of the class, they offer a new tools, a new recipe. Whether the recipe is good or not, we can see it. Okay? Look. From this structure, I transform into distance matrix. And then from distance matrix, this is the network of all locations in peninsula. It is semi-difficult to read, right? What information are there? Okay, don't worry, we have the tool to read it. Okay, we have the tool to read it. And then, because it is still difficult to read it, then we filter the information contained therein. One of the most widely used and popular tool to extract the information of network is what we call network topology based on graph theory, what we call minimum spanning tree. Okay, so then now this is the network. In 2012, the 700 locations in peninsula are related to each other like that. Okay, what Iswani is working on putting each location in the map of peninsula. Yeah, because we only know the longitude and latitude of each point here. Okay. How to read it? First, the most important measure, the most important indicator, because yesterday we were talking about indicator. Yeah? So according to box saying, yeah, according to box saying, all indicators are wrong, but some are useful. Okay? So, the prophetic words given by box is for us statisticians is energy. It is an energy, yeah, to create new tools better than the existing tools. Okay, look, according to degree centrality indicator, then the most important location to be considered when you work with rainfall in peninsula consists of 21 locations only. So focus on that location, on those locations. Before you go to the other location, focus on that. Okay? Degree 1 is the worst performance, meaning that it is influenced by the other location, but it doesn't influence other location. Okay? So 195 locations. Then look, this is 21 locations, yeah, based on degree, and then after that you calculate this indicator, and this indicator. Yeah. Okay. I would like to tell you, if you are interested, go to the book recently published in MIT. The book called Social Network Analysis. That is the most important book to understand the meaning of network topology. Okay? Those who want to know the link, yeah, you can email me. Okay? So, and then important location, yeah, according to the whole indicators consist of 57 locations. The most important one, only 2. Second most important one, this one. And third most important location is this location. And the other one is these locations, according to all indicators. Okay. So in this case, your study will be focused not on 720 locations, but only on these locations. Okay. Future research. Those who want to conduct future research, please join us. Yeah. Look. The data provided by NASA is around 15 years. Okay. So you see here that in each year you have this kind of network. Okay. So during 15 years, you have a time series of network. Look, yeah, look. Those who are working in time series, yeah, look, usually in degree program, to time series of 1 univariate data. Yeah. In postgraduate level, should be 1 multivariate data. And then go beyond there, should be 1 of matrix data. Beyond that, look, now you have time series of networks. And based on 15 time series of network, you forecast what kind of network after 2012. Okay? So, those who want to join us, please, you are welcome. Okay? I think that's all. We have so much time for discussion.
Okay, thank you, Prof. Maman. We have exactly 25 minutes. You have another 5 minutes if you want to have anything that to ask. Any ambiguities or clarifications? Or you can stand up and say, I want to join Prof. Maman in this project.
Measure the rainfall on ground using check gauge. You get 15 mm rainfall. How does the satellite know how much rainfall?
This is in mm. Yeah. Year 2012, January, 1st January, location. This is the longitude, this is the latitude. First observation for first hour, 0 mm. Yeah. Second observation, first hour, until 8th observation, first hour. Okay? 0.03. How?
How does the satellite, I mean, from ground observations you can observe 0.03 mm.
We have to go to NASA to ask them how. This is the amount of rainfall in this place. The amount. The location, better you ask the NASA. Yes, yes. It is certificate. Just give me your data and I give you the result.
Another question is, I know that the analysis, but in one of your slides, the result, you say that you
This one?
No, the previous one. Can you explain? We have the degree 4, which you say is the best, right? The frequency 21, I assume is 21 specific locations where the data was collected. Is it? Which will be further used for analysis. Is it?
Are you familiar with the word?
What?
Are you familiar with the word?
No.
Yeah.
Because I want to know how we can use the information to actually explain the behavior of the rainfall.
Look. How can I explain this? Okay, look. Let's say we have 30 people here, right? And we can create a network based on relationship between two persons. Okay? The same relationship. Then after that, what do you think? If one person has more link than the other one, so this person is very influential, right? That's it.
So you have 21 influential person.
21 influential locations. Depends.
Do you have the spatial distribution of that 21 locations?
Yes, but this one is still working on that. We want to put those 720 locations on Peninsula map. Okay? It's still on us. If you have real data that you collect, oh, it's very beautiful. Yeah. But at least I show to you. In using statistics, you are free. Your mind is free. Yeah. To be developed. Don't focus on one single data. Okay? Let's say, if you use BCA, there are so many traps there. I was working on BCA for robotic in France in 1977. There are so many traps there.
Okay, thank you very much, Prof. Maman.